Hey everyone, today we are looking at a line defined by the equation y is equal to 2x plus k, and we want to find the value of k, i.e. the y-coordinate of its y-intercept, such that the line runs tangent to the parabola defined by y is equal to negative 1 over 2x squared plus 7 halves x plus 1. Now, if we think about this on a graph, very generally speaking, I'm not trying to accurately graph these two functions, but a tangent, a line running tangent to a parabola is going to look something like this. It's going to look something like that, okay? So it's going to be some parabola, and the line is just going to graze that parabola at one unique point only, and then continues infinitely in both directions. And so what that means for us is that if a line is in fact tangent to our parabola, it means it only intersects with it one time, meaning that we only get one point of intersection, meaning that our system of equations defined by these two equations has only one unique solution. And so if we're going to find their point of intersection, because if it runs tangent, it still touches that parabola at one point, meaning that that point is in fact a point of intersection, right? And to find points of intersection inside of systems of equations, we set the two equations equal to one another, or we use substitution or elimination. But in this case, since y is conveniently already isolated for us, in both cases, we can set them equal to one another, right? Set the first y equal to the second y, right? In that case, that means that the first equation, 2x plus k, is equal to the quadratic equation like so, okay? Now, we want to find the value of k that provides us with only one solution to this equation, okay? Keep that in mind. So if we go about solving it the same way we would any other quadratic equation, right? We're going to set one side equal to 0. Set one side equal to 0. This one seems like the easier of the two. It doesn't matter which one, but we have to pick one. So let's subtract 2x from both sides and subtract k from both sides like so, minus k. So both of these terms go away, and all that's left on the left-hand side is 0. So we have 0 is equal to, on the right-hand side, we still have negative 1/2 x squared. Then we have 7 over 2x minus 2x. I'll remind you that minus 2x is the same as negative 4x over 2, right? In the spirit of getting a common denominator for the x terms. And so positive 7 over 2x minus 4 over 2x means we're left with plus 3 over 2x. And then the constant term, remember k is just some constant, is just some number, right? And so that minus k is going to be part of that constant term. This is the c value, the constant term of this new equation, okay? And so now here is the equation that we are trying to solve. We have 0 is equal to some quadratic equation. Let's make our life as easy as possible. Let's get rid of all these fractions. And I don't love having a negative in front of the x squared. So to make that doubly convenient, let's multiply both sides by negative 2 to get rid of the negative in front of x squared and to get rid of the 2 in the denominators. And if we do that, we will have, let's stick with the blue marker, we'll have 0 is equal to negative 2 times negative 1/2 is just positive 1, which is beautiful. Next, positive 3 over 2 times negative 2, the 2's cancel out, but the negative, so we'll have minus 3x. And then we'll have negative 2 times 1 minus k means minus 2 times 1 minus k, like so. We could simplify that a little bit. We could write this as x squared minus 3x. Minus 2 times negative k is plus 2k, and then minus 2 times 1 minus 2. We're keeping in mind that This entire thing is our constant term. K is just some constant. It's just some value, some number, right? There's no variable in these two terms, which really constitute as one term, the constant term. So this is our C value, if you're going to throw this into your quadratic formula. Now, there's not really any easy way to factor this, obviously, because we don't even know what K is. And so this would be a great time to remind ourselves, what does it mean to have only one solution to a quadratic equation? Well, we know that we get precisely that case when the discriminant, the stuff underneath the square root, i.e. the b squared minus 4ac, some textbooks refer to it as this triangle symbol for the discriminant. But it's the stuff underneath the square root of the quadratic formula, right? Quick reminder, your quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. It's the b squared minus 4ac, the expression underneath the square root that dictates how many solutions we're going to get. And if we want one unique solution to our equation, then we want this discriminant to be equal to 0, right? Because that means that we get, first solution is negative b plus or minus square root 0, which is plus or minus 0, which means we don't get two different solutions. We only get negative b over 2a for x. That's what we're looking for. So for this equation, we have an a value of 1, the x squared coefficient. We have a b value of negative 3. And again, being very clear, we have a c value of 2k minus 2. That's our constant term. Don't miss that. And so if we throw those values into our discriminant, we'll have b squared means negative 3 squared minus 4 times a, positive 1, times c times 2k minus 2. And we are looking for when that is precisely equal to 0. Because that would mean we get one unique solution, meaning that our system of equations has one unique point of intersection, meaning that the line is tangent to the curve. It's an important concept. So let's go ahead and solve this equation. We only have one unknown. One equation will suffice. And so negative 3 squared is positive 9 minus 4 times 1 times 2k is going to be minus 8k. And then just multiplying through the brackets, minus 4 times 1 times negative 2 is going to be plus 8 is equal to 0, like so. And now we're just solving. So we'll have 9 plus 8, 17 minus 8k is equal to 0. And we can solve that equation. So we get k is equal to 17 over 8. And that is our solution. Not a nice integer value, as I was kind of expecting, but that is indeed the value of k that would make the line 2x plus 17 over 8 exactly tangent to the parabola defined by that equation. And so again, anytime a line is tangent to a curve, it touches it at one point and only that unique point. And so that means we get one solution, meaning when we're solving a quadratic equation, our discriminant is equal to exactly 0 because of, again, that reasoning. And so that allows us to solve an equation for k, and we find that k is 17 over 8. So I hope that helps. Again, please leave comments if you have any other problems involving systems of equations that you'd like a video on, and thanks for watching.